Okay, good morning all. Today I'm discussing a very important topic of laser. What is laser? Light amplification by stimulated emission of radiation. Today I'll discuss this table of content of these points which marks in green color. Today I will discuss only content which is marks in on green color. In next lecture we have discussed the point content which is marks in red color. So first we'll discuss the laser introduction. Before going into how laser works, let's first take a look at how light is work. Before going to start of laser, first you will understand what is the light. So what is light? Light is a kind of energy released by an atom. Light is made up of very small particles called photons, and atoms are the basic units of matter, and each atom consists of nucleus and a set of electrons orbiting the nucleus. Nucleus is formed as a result of strong nuclear force between the protons and neutrons. Protons have positive charge, so they are referred as positively charged particles. Neutrons do not have charge, so they are preferred as neutral particles. Neutrons do not have charge, so the overall charge of the nucleus is positive. So what is like? Electron has negative charge. You can see easily in figure. So they are referred as negative charge particle. Electrons always orbits the nucleus because of the electrostatic force of attraction present between them. Electrons revolves around the nucleus in different orbits of cells. Each orbit has a unique energy levels, that is even E2 E3. The electrons orbiting at a larger distance from the nucleus are high in energy level, whereas electrons orbiting at a smaller distance from the nucleus have lower energy level. Electron in the lower energy levels need some extra energy to jump from lower energy level to higher energy level. This extra energy can be supplied from various type of energy sources such as light, electric field, or heat. So next, light show property of both waves and particles, so it can behave simultaneously as a particle or a wave. Einstein believed that light is a particles or photon and the flow of photon is a wave. Light is obtained from various sources like candles, lamps, and sun rays. Candle and lamps are called the man-made light source, and sun rays is called the natural light source. The first reliable artificial light source, incident light bulb, was invented in 1879 by Thomas Edison. In incident light bulb, electric currents flow through a filament inside a bulb. When sufficient electric current is passed through the filament, it gets heated up and emits visible light. Thus, visible light is emitted from the incident light bulb. Now, we will discuss what is laser. The word laser is acronyms from for light amplification by stimulated emission of radiation. Laser is a device that amplify or increase the intensity of light and produce highly directional light. Laser not only amplifies or increase the intensity of light but also generate the lights. Laser emits light through a process called stimulated emission of radiation, which amplifies or increase the intensity of light. Some lasers generate visible light, but, but others generate ultraviolet or infrared which are invisible. So in general, when electron jumps from higher energy level to lower energy level, it emits light or photon. The energy of the emitted photon is equal to the energy difference between the energy levels. The loss of electron energy is attributed to the entire atom. Therefore, it can be thought that the atom is moving from a higher energy state to a lower energy state. Laser light is different from the conventional light. Laser light has extraordinary properties which are not present in the ordinary light source like sun and incident lamp. The conventional light source such as electric bulb or tube light does not emit highly directional and coherent light, whereas laser produce highly directional, monochromatic, coherent and polarized light beam. In conventional light sources, excited electron emits light at different time and in different directions, so there is no phase relation between the emitted photons. On the other hand, the photon emitted by the electron or laser are in the same phase or move in the same direction. Einstein gave the theoretical basis of the development of laser in 1917 when he predicted the possibility of stimulated emission. In 1954, C.S. Towns and his co-worker put Einstein's prediction for practical realization. They developed a microwave amplifier based on stimulated emission of radiation. It was called a maser. Microwave amplification by stimulated emission of radiation. Maser operate on principles similar to laser but generates microwaves rather than red light radiation. In 1958, C.S. Towns and a Scalom extended the principle of masers of to light. In 1960, T.H. Maiman built the first laser device. So next we have studied the working principle of laser. In laser, photons are interacted in three ways with the atom. First is the absorption of radiation, second one is spontaneous emission, and third one the stimulated emission. So one by one we have discussed. First one is absorption of radiation. Absorption of radiation is the process by which electron in the ground state absorb energy from photons to jumps into higher energy level. The electron orbiting very close to nucleus are the lower energy level or lower energy state, where the electron orbiting farther away from the nucleus are the higher energy level. So the electron in the lower energy level needs some extra energy to dump into the higher energy level. This extra energy provided from various energy sources like heat, electric field, or light. Let us consider two energy level E1 and E2 of electron. E1 is the ground state or lower energy state of electron. E2 is the excited state or higher energy state of electron. The electron is the ground state are called lower energy electrons or ground state of electron, where electron is called as the higher energy state or excited electron. In general, electron in lower energy state cannot jump into the higher energy state. They need sufficient energy to jump from into the higher energy state. When photon or light energy equal to the energy difference between two energy levels, that is E2 minus E1, is incident of an atom. The ground state electron gains sufficient energy and jumps from state E1 to the state E2. The absorption of radiation or light occurs only if the energy of incident photon exactly match the energy difference of two energy level E2 minus E1. Next one is the spontaneous emission. In spontaneous emission is the process by which electron in the excited state return to the ground state by emitting photon. The electron in the excited state can stay only for a short period. The time up to which the excited electron can stay at high energy state E2 is known as the lifetime of excited electron. The lifetime of excited electron in excited state is 10 to the power minus 8 seconds. So, thus after the short lifetime of the excited electron, they return to the lower energy state and by releasing energy in the form of photons. In spontaneous emission, the electron move naturally or spontaneously from one state, that is high energy state, to lower energy state. So the emission of photon also occur naturally. Therefore, we have no control over when the excited electron is going to lose energy in the form of light. The photon emitted in spontaneous emission process constitute ordinary incurrent light. Incurrent light is a beam of photon which frequent and random change of phases between them. In other words, the photon emit in the spontaneous emission process do not flow exactly in the same direction of incident photon. Next one, the stimulated emission. Stimulated emission is the process by which incident photon interact with the excited electron and force it to return to the ground state. So in a stimulated emission, the light energy is supplied directly to the excited electron instead of supply the light energy to the ground state electron. Unlike the spontaneous emission, the stimulated emission is not a natural process, it is an artificial process. In spontaneous emission, the electron in the excited state will remain there until its lifetime is over. After completing the lifetime, they return to the ground state by releasing energy in the form of light. However, in stimulated emission, the electron in the excited state need not to wait for completion for their lifetime. An alternative technique is used to forcefully return the excited electron to the ground state before completing its lifetime. This technique is known as the stimulated emission. When incident photon interact with the when incident electron interact with the excited electron, it forces the excited electron to return to the ground state. The excited electron release energy in the form of light while falling to the ground state. In stimulated emission, two photons are emitted, one additional photon is emitted. One is due to incident photon and another one is due to energy release of excited electron. The stimulated emission process is very fast compared to the spontaneous emission process. So all emitted photon in stimulated emission has the same energy, same frequency and are in phase. Therefore, all photon in the stimulated emission travel in the same direction. The number of photon emitted in the stimulated emission depends on the number of electron in the high energy level and the incident light intensity. It can be written as number of emitted photons alpha, number of electron in the excited state plus incident light intensity. So today I will hold my lecture. Thank you. In the next lecture, we have discussed the characteristic of laser, what is the laser construction, method of inverts, types of laser. We have used different types of laser and very important parts of application of laser. It is very important application of laser. Please subscribe my channel.